So let's just go ahead and get a look at what this final product is going to look like. So on like an X by X grid, so whatever you want it to be, you have a little snake moving around. There's a snack, is what I want to call it, that shows up, and as you collect it, it increases the length of the tail. And then obviously if you run into yourself, and I just did that by clicking the back key while I was going forward, it gives you a little error message here. It says you ran into your tail, your length was 9, ... whatever. And then you can continue and play as long as you want. Anyways, what I'm going to be doing in here is I'm going to be coding everything object orientated. I know that there's a much faster and easier way to do this, but it doesn't really teach you that much. This way you're going to learn a bit about objects, about classes, how we can kind of work with them, and you'll see like how the flow of my program goes, and you should learn quite a bit, especially if you're somewhat a beginner programmer. What we're going to be using to make this is a module called Pygame. If you don't know about Pygame and you want to learn about it before you do this, I would recommend that. Alright, so let's start coding. So pretty much what I've done is I've just set up the flow of the program, all the classes and the function, just to remind myself what I need to write. And while I'm talking here, it's probably a good idea if you guys copy this down. So what we're going to have is we're going to have two main objects. We're going to have a cube object and a snake object, and our snake object is going to contain cube objects, if that makes sense. So each one of those little red squares that was moving around is a cube object, and the whole thing is our snake object. We're gonna have a few functions here: draw grid, redraw window, random snack, message box, and main. So let's get started with our main function here, and this is what's going to be our main loop. So essentially what I need for the main loop to start is we need to make a surface. So in Pygame, to do this, we do when equals Pygame dot display dot set underscore mode, and then I'm going to set it, let's see here, what do I want the height to be? I'm going to say width and height, like this. Oops, bad spelling. And I'm just going to make a variable here called width equals height equals, and we'll just set this to 500 by what I have, 500, like so. Now we need another variable. I'm going to set this as rows. Can delete this down here. I was going to do something, but I'll do that later. And this is how many rows you're going to have, or rows or columns, whatever. You can set this to whatever you want. Just make sure it divides 500 evenly. Otherwise, you're going to have like weird looking rows, if you know what I mean. So I'm just going to set mine to 20. That's what I'm using in the other one. But if you want to make it harder, set it to something like 10, and there won't be as much room for the snake to move around, and the games will go faster pretty well. Okay, next what we need to do is we need to set up a snake object. So I know that we haven't even created like anything in the snake class yet, but I'm just going to do s equals snake, and I'm just going to give it a position. So in this case, we want to, or a color, sorry, which is going to be red, because red, green, blue, 255 for red. And then I'm going to give it a position. We're going to start in the middle. So I'm going to start at 10, 10. Now let's move into our main loop. So I'm just going to say while flag, create my variable up here, flag equals true. And then we're just going to start by doing a Pygame tick. So pygame.time.delay. 50, like so, and that's just going to delay us, I want to say like 0.5 or 50 milliseconds every time, so that our program doesn't run too fast. I'm also just going to create this clock.tick. I'm going to put that at 10, and what I'm going to do is I'm going to create a clock object up here, and this is a built-in thing in Pygame, and what this is going to do is I'll explain in just 1 second once I finish typing it. Pygame.clock, I believe it is, .time.clock, like so. So what this clock.tick is actually going to do is it's going to make sure that our game doesn't run at more than 10 frames per second. So that would mean essentially that our snake would be able to move like 10 blocks in 1 second. And again, we don't want it to be that fast, so that's why we're also delaying by like a few milliseconds here. If you put this too low, then again, it's going to move too low. You can play around with the speed. This is kind of what I found was the best speed, and it may vary depending on what machine you're on. Although it shouldn't, it might, so you might want to just change these numbers. Again, the lower this goes is the faster it's going to be, and the lower this one goes is the slower it's going to be. So they're kind of inversely proportional, like that. All right, next, what are we going to do here? I'm just going to call redraw window. Oops. And I butchered that so bad. Oops. redraw window like so. I'm just going to give it a surface, which is in this case going to be win that we've created up here. And for now, that's all I'm going to put in my main loop here. And we'll move more into that once I start coding some other stuff. Okay, so now that we have our redraw window being called here, I'm going to go and I'm going to start coding our redraw window. So what this is essentially going to do is we first need to update the display. So pygame.display.update like so. And we also need to draw the grid. So we're simply going to do draw grid. We're going to pass it that same surface that we were given and move on from that. We're also going to fill the screen. So win.fill. In this case, I'm just going to use black. So it's 0, 0, 0. And there we are. That's all we need to do right now. But essentially, we're also going to need to draw the snake. We're going to need to draw a few other things on the screen that we'll get to later. Okay, so draw grid. Let's move into this one now. What we need to do here is draw a grid, which is pretty easy to do. So what we do is we're given rows and surface. So it'd probably be a good idea if I actually passed in the rows and the surface. So I'm just going to global them here so that I can reference them. I think this is going to work. We'll do global rows and width like that. And here we also need to make these global just because I don't want to pass them in every time I draw a grid. We're just going to say width, and rows. And this height variable is actually not necessary because we are just going to draw a square, like a square surface every time. So we can just make this the same. We don't need two variables for width and height, which are going to contain the same number anyway. So global, width, and rows. I go here, draw a grid, given width, rows, and surface. So now we're going to put in, well, first we're going to put our rows, or width, row, and surface like that. Okay, so that should be working now. In here, what we first need to do when we're drawing a grid is we want to figure out how big each square in the grid is going to be. Because what we're going to do is we're going to just draw lines going down and across, but we need to figure out where to draw those lines. So we have to figure out kind of like the gap between each of the lines. So the way we do that, I'm just going to create a variable here, size between is equal to our width, integer divided by our rows. This is just so that we don't get like large decimal numbers because that we cannot pass into our draw line method in Python. Okay, so now I'm just going to create x variable and a y variable, and I'm going to set these to 0. I'm going to say for L in range, and this is just standing for line pretty well, in rows, like that. Now what I'm going to do is I'm going to increment my x by the size between, and I'm going to increment my y by the same. So y equals y plus, size between. I can get rid of one of the spaces here. Oh, what? Okay, there we are. And now we're simply just going to draw two lines. So to draw a line in Pygame, all we have to do is pygame.draw.line, and the arguments that that takes is a surface. We need a color. In this case, it's going to be white. So we do 255, 255, 255 for white. We're going to draw at x0, xw, and I'll go through this in just 1 second, what this does. And I'm just going to copy this and draw one more and then explain how this is going to work pretty well. Okay, so now we need 0, y, and w, y, like so. Okay, so what this is going to do is this is going to draw two lines for us every loop of this for loop. And these arguments here is the start position of the line and the end position of the line. So the first line that we want to draw is going horizontal, which means we don't want to change the y value at all. So what we need to do is we need to find the x, and then we're going to put y at 0 because we're going to be at the top. I think that's right, at least. Oh, sorry, this line is being drawn down, not being drawn to the right. I was getting confused there. Okay, so we're going to change the x, but we're going to keep the y at 0, and then we're going to stay at that same x, and we're going to keep the y at the width of the screen so that we're going far enough down. And then same thing here, this one is going horizontal. Excuse me, I messed that up before. So our x is always going to stay at 0, and our y is going to be what's changing as we draw horizontal lines across the screen. I hope that makes sense to everyone, how that works. Anyways, I'm going to move on from that, and that's all we need for the draw grid function. So let's just go ahead. I probably made a mistake here, but we'll run the program and just see if everything's working. Again, our name win is not defined, win.fill. So I've called this win. One really needs to be surface, like that. So let's try now, and there we go. We get a nice little grid on our screen like so, 20 by 20 grid. There we are. So now let's move into another function. Or actually, let's start coding one of the classes here. So like I was talking about before, we're going to have a snake object, which is going to contain a bunch of cube objects. So essentially what we're going to do is we're going to have a list of cubes, and that's going to be known as the snake body. So let's go ahead and write that in now. What I want to do for that is just create a list. So we're just going to say body is equal to, and then a blank list. I'm also, just while we're already up here and creating a class variable, I'm going to create turns is equal to, and it's just going to be this set of squiggly brackets here that we'll get into in a bit. Okay, so now that we're already in this snake function, what we need to do is we just need to define our parameters here that we're passed in. So we're just going to say self.color equals color, say self.head equals cube, which I'll get into in a second, given the position, say self.body.append our head, self.head, like this. So what we're doing here now is we're saying, okay, so the head of our snake, which is going to be important because we need to know where that is at all times so we can move accordingly, is equal to a cube at the given position. And the given position is what we pass in here as like the starting position of our snake. Or we could create a new snake, like we'd have multiple snakes moving around, and anyways, that's the position. Now we're saying we're going to append to the body this head. So now this is in our list here, and then we can go through that list and we can draw things, we can move it, we can check things. We want all of our cubes to be ordered within this list, so that's why I'm putting that in first. Now I'm just going to give this one, which is called dirn x is equal to 0, and dirn y, which is equal to 1. So what this is going to do is we have a direction for x and a direction for y for moving our snake. So obviously these are going to be a value like -1, 1, or 0. And that's going to be the same for y and x. If y or x is equal to 1, -1, then the other one's going to be equal to 0 because you can only be moving in one direction at the same time. And this is just going to keep track of what direction we're moving in. And we'll use this in the next function that we're going to code, which is our move function. So moving is pretty straightforward, at least in terms of just if you have one object moving around the screen, getting it to go left, straight, right. But when you have the snake object, it has to turn at certain points. So when I click left, the rest of the snake is still moving forward. Once it reaches the point where the head turned left, then it has to turn left. So that's where things can get a bit complicated. Anyways, to start, what I'm going to do is I'm going to say for event in Pygame. Oops, what am I doing with my typing here? Pygame.event.get, like so. And then we're just going to say if event.type equals Pygame.quit, like this. And this is the first one we always want to code in because we want to make sure that if they click that little red arrow, it actually works and we can quit. So we're going to do Pygame.quit like that. And then we're just going to say if, actually we don't even need another if, because the way I'm going to do this is this other way you might have seen in Pygame before to move things around. You say like if event.type equals key down, and then you just check which key was pressed and move to the left. This is a similar thing, but it works smoother. I've used both of them a lot, and this is the one I prefer, so I'm just going to use this. So pygame.key.get_press. So what this is going to do is it's going to get a list. Actually, I think it's like a dictionary or something like that that has all the key values, and then if they were pressed or not. So that way, if you press more than one key at once when you're looping through, it'll adjust to that. Whereas the other one, you can only click one at a time, and you couldn't move like per se diagonally if you were moving like a character on the screen. It doesn't matter too much for this, but this is the way I like to do it. So now I'm going to say for key in keys, because remember this is going to give us all of the keys and then like a 1 or 0 value if they were clicked or not. So we need to loop through all of them and check. We're going to say if keys, and then pygame.key, or oops, .k underscore left. Thought it was key there. And then we're going to say if keys pygame.k underscore right, like that. And we can continue down here with up and down. And then we'll get into exactly what is going to happen when we click these keys. So last one here. All right, and there we go. Okay. So now what we're going to do is we're going to change the direction according to what key we click. So if we're going left, that means that our x has to be negative, because the way, again, coordinates work in Pygame is in the top left-hand corner of your screen is 0, 0. So if we want to be moving left, we should be making our x negative to move more towards 0, right? If we want to move right, then we make our x positive, which would be 1 in this case, because we're just going to move one cube at a time to go further to the right. Same thing with the y. It's kind of weird in Pygame how the y works, because the more y you add, the further down you go. So we'll do that in a second. So for x, we're going to say self.dirn x equals -1, again, because we're moving left. And we're going to set our dirn y equal to 0. And this is because, again, we don't want to be moving in 2 directions at once and be going diagonally. Now, this is what I was talking about, is we need to remember where we actually turned. Because if you just have one cube moving around, that's fine. But when you have multiple cubes, we need to be able to turn left. Right, we need to remember where we turned so that the tail of our cube can turn at that point. So that's why we have that self.turns list up here, or just this turns, I want to say dictionary or set, whatever. So we're going to add to that. We're going to self.turns, and we're going to give it a new key. And I'll go through how this works in a second. Self.pause here is equal to, and then we're going to give just a list of self.dirn x and self.dirn y. Okay, so you might be kind of confused on what's going on here. So I've created a new dictionary up here. That's what I'm going to call it officially. You could think of it as a set as well. And pretty much we're going to add a key, which is the current position of the head of our snake. And then it's going to be set equal to what direction we turned. So we're saying we have a new turn at this position, and our character or our snake moved left. So it's going to say we have self.dirn y, which is right here as -1, surf.dirn x, sorry, and then dirn y is equal to 0. So we know what way we actually turned. And I hope that makes sense. That's yeah, that's how we're going to do that. Now I'm just going to copy and paste these and then change these values. So when we're going right, this is going to be 1. Oops. Same thing here. So we'll put that in. This is going to be 0. And dirn y, we're going up, is going to be -1. Now when we're going down, we need to change this to 1 and this to 0, and I'm just going to get rid of that. And there we go. Okay, so that is pretty much how we go about doing this. And I can also just put elifs here as well, because we don't want to be able to move in more than one direction. So we're going to prioritize the left arrow key. If they're not clicking the left arrow key, then we'll check if they're doing the right, otherwise up, otherwise down, because we don't want them to be able to click more than one key at once. Okay, so next we need to actually move our cube. And this is where it gets a little bit more tricky in terms of looking where our cube is, and if it's at that turn, then we're going to turn it. So I'm just going to start coding, and then I'm kind of going to go through exactly what I do. So for I, C, and enumerate. Oops. And I spelled that wrong, didn't I? Like that. And then we're just going to say self.body, because we're going to look through the list of positions that we have on the snake. And we're going to say p equals c.position. And I'm just going to copy this. By the way, that's what this little arrow does here. It just makes a copy so that we're not changing the position of our snake when we do things. It's just follow along with it. It's not super important. Okay, so we're going to say if p is in self.turns, like this. Because remember, what we did is we added the position of our head 2 turns. So now we're going to say, well, if this position is in the turns, then we're going to move. Or we're going to turn, right? So let's say here, so we're going to say turn, oops, equals self.turns p, like that. So now we've seen that it's in there. So now it's in there, we can find the index of it, and we can grab the direction value so we know what way we're going to be moving. And now we're just going to say c.move, like this, and turn 0, turn 1, like so. Okay, now next, I'm going to say if I equals the length of self.body minus 1, oops, then I'm simply going to do self, I don't know why that's capital, self.turns.pop p. Okay, so I know I just did a lot of coding here, and this probably doesn't make a lot of sense to you guys, so I'm going to kind of run through exactly what I just did. It's a little bit difficult to explain. So anyways, what we start off by doing is we're going to say we're going to get the index, and we're going to get the cube object in our self.body, because remember, our self.body is made up of cube objects right here that have these properties, right? They're going to have a direction y, direction x, a start, a color, so on. And we're going to get to coding cube in just a second. So they're cube objects. Now all of these cube objects have a position. So I'm saying for each object here, I'm going to grab their position, and I'm going to see if that position is in our turn list. And we create the turn list and add to the turn list when we turn, right? When we click left, center, right, so on. And then we're going to say, okay, so the actual turn, so where we're actually going to be moving, is equal to the turns list at that index, right? So we grab the turn, direction x and direction y, which we stored there. And now we're just going to say our cube.move, which is another method that we're going to code. And we're giving it that direction x and that direction y, so it knows what way it needs to move pretty well. And then I say if I is equal to the length of self.body minus 1. So that means if we are on the last cube, we're going to remove that turn. So once that last cube hits that turn, we're going to remove it. Because if we were just to leave that turn in the list, then that would mean any time you hit that position on the screen, regardless of if the snake was turning there or not, you'd automatically change directions if you don't remove it from the list. I hope that makes sense. Okay, now also after this if here, we're going to say if the, if it's not in the list, so if our position's not in the list, we still need to move the snake because it's constantly moving. So what do we do to this? Well, we write an else, and I'm just going to copy this in because it's going to take a second to type because I have another file open, and I'll go through what happened, how this works. Okay. Now this looks like a lot, but pretty much what this is doing for us is we're checking whether or not we've reached the edge of the screen. So we're saying if we're moving left and the position, so the x position of our cube is less than or equal to 0, then we're going to change that position so that it goes to the right side of the screen. So the way that we can do that is by saying c.rows minus 1, because again, you start counting at 0 in computers. So if our rows is like 20, then the last cube would be 19 in a list, right? So say c.rows minus 1, and we're going to be at the same y value, so we'll leave that there. Okay, and then we say otherwise, we're going to check if we're going right, if we're moving right, and same thing if we're at the edge of the screen, move back to the left side by putting 0 here. And then next one, if we're going down, what we're going to be doing is, again, checking, are we less than rows minus 1 or greater than rows minus 1? No, we're not. Or if we are, then let's move us back up to the top of the screen by changing our y value. And then same thing here if you're moving upwards. Now, if none of that's true, so we're not at the edge of the screen, we're not moving up, left, down to whatever I just said, then we're just simply going to move our cube at the direction x and the direction y of that cube already. So if that cube is moving upwards and it's not turning and it's not going to the edge of the screen, it doesn't need to be changed, just keep moving it in whatever direction it's going. And that's why I'm simply referencing the cube's already existing direction x and direction y. We're not changing anything, we're simply just saying, okay, let's move you forward 1, like that. I hope that makes sense. That was a lot, and that's probably one of the hardest things in this program is figuring out the movement of the snake. So if you guys understand that, then that is the hard part kind of over with. And we're going to get into this cube object, so you're going to understand what all of this means and how our rows and columns kind of work and stuff like that. Okay, so I'm just going to forget about reset and add cube for now because we'll worry about those later. But let's get into the draw method because we want to see if this is actually working and put this on the screen. So simply for I, C, and enumerate. Why can I not spell enumerate today? Like that. Same thing, self.body, like that. We're going to say if I equals 0, c.draw, and you'll see why it is in a second. True. Else c.draw surface, like that. Okay, so the reason I'm doing this little check here rather than just drawing every object is because when we draw the first snake object, I'm not sure if you remember my other program, it had eyes. So what I would simply want to do is make sure that when we draw that first object, we add eyes onto it, just so we know where the head of the snake is. We don't get confused like what direction it's moving in. Although you shouldn't, I want to add the little eyes, maybe just for aesthetic as well. So what this true does, optional parameter, simply says draw eyes if it's the first one in our list, like that, if it's the head. And then in this draw method, you can see I have eyes equals to false, but when you make it equal to true, we're going to do a special thing in here that's going to draw eyes for us. Okay, so now that we've coded this whole mess of stuff in the snake class, let's just run the program quickly and see if anything's happening. So currently we just have the grid. We don't have any errors or anything, but that's because we haven't drawn the snake object onto the screen yet. So what we need to do is we just need to simply do s.draw within our redraw window here. So I'm just going to type, I'm going to global s here, and I'll global it down there as well. I'm going to say s.draw like that, and we need to give it a surface. So let's give it a surface, and I'm just going to global s so that we can reference it there. And is there a reason we aren't being drawn to the screen? Let's just have a look quickly. S.draw. S.draw. Oh, it's because, yes, we are indeed drawing S, but we haven't drawn any of the cube objects yet, and it is calling the draw method on all of our cube objects, which we haven't yet created. Hopefully that makes sense, but we'll go ahead and do that now. So we have to code a little bit more before we can see everything. So let's just go ahead and get into the cube object here, and let's just say self.start equals start, except I'm actually just going to change this to position because I believe this is what it's supposed to be. And then we're going to say self.turnX equals 1, self.turnY is equal to 0, and self.color is equal to color. And the reason we have this is because we're going to be drawing later what I want to call like a snack for the cube to collect, for the snake to collect. So we want to be able to change the color with that. And spelled it wrong like 3 times during X and during Y. The reason I have during X here set to 1 initially is because I want to make sure that we start moving in a direction. If I had this at 0, you would have to click a key before the snake starts moving, but I want right when we run the program for the snake to just start moving, so I'm setting it already with a direction X. And the reason these are optional again is so that when we create a new cube object, we don't have to implicitly say direction X is 1, direction Y is 0, because it's assumed that it's always going to be like that unless otherwise stated. Okay, let's have a look. What else do we need to do here? We need to now code this move function, which is actually really easy. All I'm just going to do is we're going to say, since we're changing the direction X and the direction Y in our snake class, we need to do that in here so that it stays with the object. I'm going to say during X equals during X, and then same thing, self.during Y equals during Y, like that. And then we'll go down here, and all we're going to do is we're going to change our position. So self.position is equal to self.pos 0, which is our already existing position, plus self.during X. And they're saying self.pos 1, which is our already existing Y value, plus equals self.during Y, like that. And just in case I haven't mentioned it here, right, we're working with a grid system of 20 rows in this instant. So when I say something like, if our self.position is like 1, 3, or 10, 10, I'm saying we're in the 10th row in the 10th column. I'm not saying the X value is equal to 10 and the Y value is equal to 10, because it's not in the case of drawing on the screen, because our screen is actually a width of 500 pixels, but just where we are in the grid, which is most important to us right now, is equal to like that value. It's like 1, 4, or 3, 5, so on, like that. Just to make that clear for anyone who might have been confused. Okay, so now for drawing, it's a little bit harder just because of what I mentioned as well, is the fact that we need to figure out the distance between each X value and each Y value. So when we're drawing something in Pygame, it draws in the top left-hand corner of the object. So if we draw a cube, we're drawing that in the top left. So we need to figure out what that X and Y value is going to be for each cube when we're drawing it to the screen. So I'm just going to call this gap here that is going to be our distance, and then the same thing, self.w by self.rows. And we're going to change W and rows down in our program later. But we can actually just type it in now, like this, so 500 and 200, just so we have that set. Okay, so self.w, integer divided by self.rows. Again, that's the same thing we did when we were drawing the grid to figure out the distance between our X and Y values. Okay, we're going to say I is equal to self.pos0. This is going to save us a bit of typing in our function here, or in our method. We're just going to say j.self.pos1. So we're just saying I, which stands for row, j stands for column, like a classic convention for it, so that we don't have to keep typing pos0, pos1 when we move. Okay, so the next thing we need to do is now draw a rectangle. We're going to say pygame.draw.rect like this, and then we need a surface. We need a color, so self.color, and then we need a rect. And here is a little bit of math. I'm just going to type it and I'll go through exactly what it does. J multiplied by dis plus 1, dis minus 2, dis minus 2. Okay, so the reason I have these little plus 1s and these minus 2s here is just so you can still see the grid when we draw the rectangle. Because if we were to draw with exactly the dimensions of this distance, then what would end up happening is we'd cover the white lines of the grid, and it just looks kind of weird if you can't see the white lines. So that's why I have plus 1 added here and minus 2, just so we're drawn inside of the circle, or inside of the square a little bit, and you'll see that in a second. So what I'm simply doing is I'm multiplying my I value, which is going to be my current row column, by the distance that we need to get to the next one, and then same thing for j, and then these little add 1s, minus 2s is just to make sure that we stay inside. So a quick example, if you don't understand, is say we're in a position 0, 0. So our I is 0 and our j is 0. We're going to say I multiplied by distance. Let's say distance is like 40. Okay, so 0 multiplied by 40, 0. 0 multiplied by 40, 0. So our position is 0, 0, and that's correct because if we're drawing in the top left-hand corner here and we're in position 0, 0, then that's where we should draw. Again, if you go something like 0, 10, and you move down, I guess, so 10, you're moving wide down, you're going to say 0 minus distance, 0, and you're going to say 10 multiplied by distance, let's say it's 40, then we move to that correct position down the screen. So this is rectangle XY width height. Okay, makes sense. Now the next thing we need to do is we need to draw the eyes. Now you can skip this part if you want. I'm just going to copy it in because it's a little bit of math to make them perfectly aligned on the square. But yeah, so we say if eyes, and we're saying our center is equal to distance modulus 2, because that's going to be the center, obviously, or modulus, what we're saying, divided by 2, is going to be the middle of our cube. And we're saying the radius, that's how big the eye radius is going to be. And then we go through a little bit of math here. So circle middle is going to be I multiplied by distance plus center minus radius. And then we're finding out the x. And this is just a random x that I'm setting by just putting it 8 pixels up every time because I don't want to calculate the x. I don't feel like doing that. And then I'm drawing 2 circles based on circle middle 1, circle middle 2, and then the radius and a color of black. Or a color of white, actually. Sorry. Or no, that's black. I'm confused. All right. Anyways, with all of that being said and done, and you guys probably pretty confused right now, let's just run and see if anything's actually happening. And you can see we have a cube in the middle of the screen. Yay, so that's all we've done with all this coding so far, is drawn a cube. So actually not quite, because we still, all we have to do now simply to start having that cube move and seeing our key presses work is just do a little bit in the main loop. So let's move down to the main loop now and have a look here what we need to do. Okay, so what I'm going to do is I'm simply just going to call s.move, which is our snake object, every time this main loop runs. And what this will allow us to do is, I want to call this before I redraw window, is it's going to go up to that method in snake. It's going to check every time that we run the loop if a key has been pressed. If it has, we're going to move accordingly. And remember that in this move loop here, it moves all of the objects for us. So it moves all those cube objects. And then we're just drawing the grid, we're drawing everything in this redraw function, so it'll just display that and update that to the screen. So let's see here, and we get an error. Tuple object is not callable. Self.pos0 plus self.thereNext. Alright, 1 second, guys. Oh, it's because I've used curly. Okay, so apparently I am an idiot and I forgot to add an equal sign here. So the issue was simply that this looked something like this. Then I changed it to square brackets when all I needed to do was put an equal sign like this, and now we should be up and working. So to reiterate the line here, that the issue is at, you guys probably saw this when I coded it, to be honest, is in move, in cube, it's near the top of the program. All you have to do is change this, add an equal sign between this, the bracket and the pause. So now that we run it, we can see that we have a moving object, and that we can move up, down, left, right, etc., so on and so forth. like that. Okay, so play around with that for a second, and now we'll get into adding cubes. And we're actually almost done. We just need to add that add cube function, message box, a little bit in the main loop, and then we'll be finished. Okay, so what we're gonna do now is, that's all great, we're moving around, but we need to add stuff to our cube, right? Like we need to progress the game. So to do this, we are going to generate what I want to call a random snack that we're going to place on the screen that our snake can't eat. So the way that we do this, I'm just going to say positions equals item dot body, and this item, oops, shouldn't be item, should be item. It's just going to be a snake object. I don't know why I'm calling it item, but that's what I'm calling it. And we're simply just going to set like a new list equal to that list, so on. Okay, so now we're going to say while true, capital T, we're going to do x equals random dot rand range. If you haven't imported random yet, make sure you do that. And y equals random dot rand range rows. And rows again should be global, so let's just make sure that this works. So global rows, like that. And then after this, we're going to say if, I don't know how I just typed that, but the length of, and I'm doing something fancy here, and I'll explain what this does in a second. Okay, so I know I just typed this stuff that probably makes absolutely no sense to you guys if you haven't been using Python for a little bit, but pretty much what this is going to do is we're going to get a list of a filtered list, and we're going to see if any of the positions are the same as like the current position of the snake pretty well. So what we're doing is we're saying that we want to make sure that we're not going to put a snack on top of the snake. Because if we have a really long snake, the chance of that happens is actually somewhat high. And I didn't do this when I first coded the game. So what would happen is when you have your snake moving around the screen, all of a sudden the snack would pop up, but it's like on the tail of the snake, which you don't want. So what this is doing, and just type it out, you don't really have to understand it, is we're saying this means a function, z, and we're just checking if the z.position is equal to xy. So if it's equal to xy, which is the position we just generated here by getting two random numbers, so x and y, then we're going to have to do this again. So we say continue, and else we break, like that. And then I'm just simply going to return in a tuple or a tuple, whatever you want to call it, xy. Okay, so this is confusing, but you can do this in like a much longer way with a for loop, where you pretty much loop through every position in this list. You check it against x and y. You see if it's the same. If it's the same, then do this loop again. Otherwise, you break and you return xy. That's all we're doing in there to generate a random snack. Anyway, message box, we're going to leave that. And in here now, what we're going to... Okay, so now that I've created this this random snack function, what I need to do is I need to use it. So I'm just going to create a new object. I'm going to call this snack, and it's going to be equal to another cube, right? Because we want to have the same functionality. We want to be able to draw it, possibly move it around, right? So we're just going to create a new cube object. We're going to give it a position of a random snack, which is going to be something like this. Oops, random snack. And then random snack, I believe, oh, it takes a row and an item. So what we're going to do is we're going to give it row, or rows, and we'll just give it our item, which is going to be s. And then after that, what else do we need for cube? I don't think we actually need anything else. I think that's all we need. Oh, I'm going to change the color. That's what I want to do. I'm going to change the color equal to green. So red, green, blue, 255 for green, so that it shows up and is visible on the screen. And now what I'm going to do down here in this while loop is I'm going to say snack. I'm going to check if the head of our snake has hit the snack. And if it has, we're going to add another part to the body of the snake. Otherwise, we're not going to do that, right? And then we're going to generate a new snack and so on. So we're just going to say if s.body 0.pause, and this is going to be the head, right? Because we have it ordered. I don't need those brackets. Is equal to snack.pause. And remember, these are both cube objects, so this works fine because they're going to be tuples. Then what we're going to do is we're simply going to say s.addCube, which is a method that we have there that we haven't actually written yet. And we're just going to say snack is now equal to, well, a new cube. So I'm just going to copy this, and paste it here. So all we're doing is now generating a new cube for snack. I'm sure I could put something in that like changed it, but this is just a way that works. Okay, so now that we've done that, we should be able to move around the screen and get the snack, but we need to code in the add snack method here, which I believe I have here, or add cube. So the add cube is pretty straightforward. We just have to figure out where we're adding that snack, or where we're adding that cube. I don't know why I keep calling it snack, to the list. So what we're going to do is we're going to figure out where the tail is, and we want to add it after that tail. So tail is equal to self.body -1, the last element in that list. We're going to say dx dy, which again is going to be our direction x, direction y. I'm just shortening it here. It's going to be tail.dirnx and tail.dirny, like this. Now again, you could do this in 2 lines. I'm just doing it like this because it's faster. And now I'm going to copy some again, and we'll just go through exactly what this does. Okay, so pretty much this looks complicated, but all it's going to be doing is checking what direction that we're currently moving in, like the head of the cube, or the tail actually of the cube is moving in, so that we can then make sure that when we add that cube, we know where to add it. So if we're adding it like to the right of the cube, to the left of the cube, above it, below it, and we can give it the correct direction to be moving in. So pretty much what we do here is we just say we're going to append a new cube to our body, and its position, if we're moving to the right, which in here we are because dx equals 1, is 1 less than the x position of that tail. So whatever the last cube is, 1 less than that, and that's so that we don't add a cube per se to the right when we're moving to the right, and then we're just going to have overlapping cubes and you're not going to be able to see them, right? Same thing down here. If we're moving down, that means, or not down, sorry, if we're moving left, that means we need to add the cube to the right side. So 1 plus that tail, the x position of the tail of the cube, or of the snake, sorry, so that we can have it in the proper position, right? And the same thing here with x and y, or with y, so that when we're moving up or we're moving down, then we add it above, otherwise we put it below. Sorry, I just stumbled through that because there was a lot of different words that are very similar. Anyways. What we need to do now is simply set the direction for that cube. So now that we added it in, if we just left it like that, it wouldn't be moving anywhere. So we just need to change that to the current direction of that tail. So whatever the tail is moving, that's where this new cube is going to be moving in that direction. So we're just going to say self.body -1.dirn x equals dx. And then same thing down here, except we're just going to change these to y. Dirn y equals dy, and that again is just the where our tail is moving at that current moment. Okay, so now that we've got all that done, it's time to see what syntax error we get next. Name rows is parameter and global. 1 second. So I've actually never even ran into that error. Oh, global rows, and it's okay. So let's just make this R, and let's change this to be 1 second. So we can just get rid of this. And this should work. There we go. So now we move around like this. The only issue is our snack is not being generated on the screen. And I don't know why that is exactly happening. Oh, it's because we're not drawing the snack. That's why. So now I'm just going to global snack up here. I believe that's what I called it. And I'm simply just going to say snack dot draw, like that. And I got to give it a surface. So let's give it a surface. Let's run. And error, name snack is not defined. It's because I didn't global it down here, so let's global that. Okay, so now we have the snack. It's on the screen, and you can see that when we collect it, we have that cube added to the end of our snake. And that pretty much is almost the game done. So all we need to do now is write that reset method, and then we need to just simply check like when we lose. Like right now the snake can go through each other, right? Through itself, and you can see we have a huge error when the snake can go through itself. So we need to make sure that when we hit ourselves, we like end the game, and we need to write that message method as well. So to do this, again, I'm just going to copy in this for loop, and then we'll kind of go from there. So let's move in here. Okay, so for x in range, the length of s.body, we're going to say s.body x, which is going to be, we're just looping through every cube in our snake body. We're checking if the position is in a list of all the positions after. That works. That's how we're checking the collision. If you want to do it your own way, go ahead, but this is the way that I like to do. Okay, so now what I'm going to do is I just want to print to the console like their score, just so that I know what it is. We'll say score, oops, and then we'll just say plus is the length of s.body, but this is going to have to be converted to a string unless I put a comma like that, so let's just do it like that. And then I am going to simply display a message box. So we'll say message box like this, message underscore box. We have a subject and we have content, and we'll do that in just a second because I haven't yet actually coded that. And then we're going to reset our snake by just doing s.reset, and this is going to take a position, which is going to be our starting position again, 10, 10. And then we're going to break out of this for loop, because if we collided once, we don't really care if we collided again. And we'll go back and we continue the game with a snake that has length 1 now. Okay, so our reset, this is pretty straightforward. All I'm doing in this reset is I am just going to get rid of our turns. I'm going to get rid of our body, and I'm just going to change like the direction X and the direction Y. So maybe it's faster if I just copy it in, and you guys can just copy this out. So pretty much all I'm doing is I'm setting a new head, which is going to be equal to, again, like whatever position we give in, because we can move it at a different position if we wanted to. I'm clearing self.body, which is again a class variable here, and then I'm adding head. I'm setting turns equal to blank, direction X is 0, direction Y is set to 1 again, so that we start moving. And you can see it's pretty much exactly what I have typed out here, except I'm just resetting the turns list. Okay, so now that we've done that, all we need to code is message box. So this one's pretty easy. You can see up here, just in case you haven't looked yet, I import tkinter as tk, and then from tkinter I import message box. Now this is how you create a message box in Pygame, and this is how you create one that actually shows up on top of the screen, and that doesn't like float kind of below it, or doesn't show up right away, if you want to say that. So just watch. This is extremely useful to use in other programs too, if you copy out this function and then you just drag it into other ones. So attributes, topmost, comma, true. What this simply does is we're creating a root, oops, which is not root.tk, it's root equal to tk.tk, which is going to be a new tkinter window. We're making sure that this window is going to be on top of anything. So if we have like a bunch of different windows open, it just comes up on top, which is what we want. I'm just going to simply make this window now invisible, and I'll explain how this works in a second. And then from this message box, what do you call it, method, class, whatever, I'm just going to say message box.showInfo, and then we're going to do subject and content. And this just takes a few more parameters as well if you want, but pretty much this just shows info given whatever subject we type in and whatever content we have. And now I'm going to say try root.destroy like that, except, oops, pass. And don't ask me what this does, because honestly I don't know, but it just works. So pretty much it shows this message box, and I'm actually pretty sure the way that this works is it constantly keeps trying to destroy the message box until eventually you click the X button, and then it actually can. I think it's like something like that. So anyways, that's how you create a message box. And with that, all we need to do is add a subject and content. So I'm going to say you lost, and our message will be play again. ... Let's run the program for the last time and make sure everything is working. So there we go. I just need to get my snake to a length that is large enough to the point where I can actually hit myself. Oh, okay, and there we go. So pretty much we ran into an error. What is the error? I spelled attributes wrong. That is a lovely error to run into. Let's run back up here. Attributes, attributes, attributes. Where did I even make this function? I must have scrolled past it. Alright, there we go. And I believe that's correct. Let's try this now. So I'm actually just gonna go, let's see if I can, there we go. Okay, so we get a message that says you lost, play again. And the reason I died there, by the way, is because while I was moving right, I moved left. So technically, the head of my snake actually ran into another part of it. So it says you lost, play again. And you can make that say exactly what you want, and then we can see that our guy just continues to move, so on. So anyways, if you guys want to see more content like this, go check out my channel. It is named Tech with Tim, and I have a bunch of videos teaching stuff like Pygame and doing a bunch of Python tutorials. You guys will definitely learn a lot following through some of my videos, and I would be very grateful if you guys went over there and liked some of my videos and subscribed.